Hello again. This geometry video will cover the theorems in the first section of chapter 5. These include the perpendicular bisector theorem, the converse of that theorem, the angle bisector theorem, and its converse. The proofs for these theorems we will review another time in class. The goal of this video is just to give you a dynamic visual representation of these theorems. So let's start with this segment BC. The perpendicular bisector is this line right here. And we've constructed these a bunch of times in class. What we end up with is an intersection through the midpoint of the segment at a 90-degree angle that bisects the segment, makes two equal halves. So what we're interested in is this point A, as it moves along the perpendicular bisector, what relationship will it have with the endpoints? So let's take a look. Turns out that this point A, as long as it's on the perpendicular bisector of segment BC, will always be equidistant from B and C. So here's the conditional statement. Come on. For this theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. The converse of this theorem is, of course, the exchange of the hypothesis and conclusion from the original theorem. So now what we have is, if a point is equidistant from the endpoints of a segment, which point C is, we have the dynamic measurements right up here showing, and we have our congruence marks, that C is always equidistant from B and A, we can then conclude that it is on the perpendicular bisector of this segment. So even if that perpendicular bisector hasn't been constructed, if we were to construct it, it would always intersect with this point C, given that C is equidistant from A and B. The angle bisector theorem. Let's look at what we're starting with. I have this adjustable angle, and the angle bisector is this line which cuts the angle measure in half, perfectly in half. No matter how I adjust, this is always bisecting the degree measurement of the given angle. So let's look at this theorem. It says if a point is on the angle bisector, which point A is, has been constructed in a way where it will always be on the angle bisector, then it is equidistant from the sides of the angle. Now remember, when we measure the distance from a point to a line, it seems like there would be a lot of different ways that we could measure that distance. So how do we define the distance from a point to a line? We did this earlier in the year. This measurement always has to be perpendicular. And in this theorem, if point A is on the angle bisector, then it will always have an equal distance, and distance has to be measured perpendicular. So AB and AC are always congruent. Their distances are equal. The converse of this theorem, again, we exchanged the hypothesis and conclusion from the original angle bisector theorem. Now we say if a point is equidistant from the sides of the angle, which A is, even when I adjust this given angle, we see that the distance is always the same from A to this side and from A to this side. We can conclude that point A will be on the angle bisector. Thanks for watching. Keep practicing.